All right, today we're going to talk about the double angle identities. And as you see my page, I printed it and now I have found my mistakes and I've edited my page as I worked through it. So hopefully there won't be any errors or mistakes on your notes. But this is lesson 23 and we're talking about double angle identities. We're going to do this in 2 videos to explain what we're trying to do today. So hopefully you copied your identities out of your book. And sine of 2u just has one form, 2 sine u times cosine u. Cosine 2u has 3 different forms, and you can use any of those forms, but probably the information given to you would determine which form would work best. And then the tangent of 2u is 2 tan u divided by 1 minus tan square u. We are going to prove these identities today, which is going to be super simple because each of these identities are based on one of the sum identities. So I'm going to walk through this and hopefully you can follow me. So if I'm trying to prove the sine of 2u, 2u means the same as sine of u plus u. U plus u. My first angle is u and my second angle is u. Now, if you remember your identities from yesterday, if you were trying to do the sine of u plus v, it would be the sine of the first angle, the cosine of the second. Well, in this case, the cosine of my first angle, the sine of my first angle, which is u, cosine of my second angle, which is also u. In the second part of the sum, it would be the cosine of the first angle, sine of the second. So I've written that here, cosine of the first angle, sine of the second angle. But for us, our first and second angles are both u angles. So I would use the commutative property. Do you know what commutative means? Just switch in the order. So I'm going to switch that cosine u, sine u, into sine u, cosine u. Just switch the order. And now I see that I have 2 expressions that are just alike. So I have 2 of those. So there's our 2 sine u, cosine u. We simply did that by the sum identity for sine. We're thinking of 2u as being u plus u. We took that identity from yesterday and we simply expanded it out and then simplified it. All right, the next one we want to talk about is cosine of 2u would be cosine squared u minus sine squared u. Now you probably have kind of caught on that we're going to be using that sum identity for cosine yesterday. So if we had cosine of 2u, we're going to be thinking about u as u plus u, right? So the 2u is going to be u plus u. So the cosine of 2u, which is u plus u, if you think about it, it's the cosine of the first angle times the cosine of the second angle, but they are the same angle. And remember, if this was plus, this operation turns into minus. Sine of the first angle, sine of the second angle. Well, cosine times cosine is cosine squared, and sine times sine is sine squared. So that's how we get the first double angle identity for cosine of 2u. Now the other 2 are based on what we just proved. We just proved that the cosine of 2u was cosine squared u, sine squared u. And all I'm going to do here is use a Pythagorean identity. I'm going to change sine squared u into 1 minus cosine squared u. That's one of those Pythagorean identities we studied before spring break. I'm going to distribute this minus sign across here, so that becomes minus 1, but minus a negative becomes plus cosine squared u. So I have 2 of these, 2 cosine squared u minus 1. To prove the third one for cosine of 2u, I will start out with that cosine squared u minus sine squared u, and you probably know what we're going to do this time. We're going to take that cosine squared and replace it with a Pythagorean identity. cosine squared u is really 1 minus sine squared u. And then there's the minus sine squared that we hadn't touched. 1, there's one of these, two of those, so that's 1 minus sine squared u. Now you probably are going to run out of paper, so you can either turn over on the back if you printed single page, or you can go to notebook paper, whatever you might need to do at this point. I just printed mine on the back. So I'm doing the tangent of 2u. I'm thinking about that as the tangent of u plus u. From our tangent sum identity yesterday, it's the tan of the first angle plus the tan of the second angle divided by 1. Since that's plus, this is minus the tan of the first, the tan of the second. But they're both the same angle. So one of these plus 1 makes 2 of those in the denominator. Tan times tan makes tan square. So it should be a pretty easy notion of how those are proved. Now I want to talk about what we're going to be doing next, and then I'm going to stop this video and kind of let you soak up the proofs before we start the second part of this explanation. It says, when we use double angle identities, we do not work with angles from the unit circle. Because if you double any angle from the unit circle, you get an angle that's in the unit circle, or an angle that's coterminal to a unit circle angle. And for example, if I'm using u to be 30, well, when I double 30, I get 60, and I already know all of the trig values for 60, so that wouldn't be worthwhile for me to use that. Same thing is true as if we double 240, we would get 480, but I already know everything I need to know about 480 because it's coterminal to 120. So I will not be using the unit circle angles or anything that's coterminal to that to work these problems, because it would kind of be doing a lot of extra work for nothing, because I know this information. All right, so I'm going to stop this, and then we'll come back and actually see how to work the problems.